Before we jump in, let's quickly review what we learned today in terms of our order of operations. You may have turned those 4 steps that are in your textbook into this nice neat acronym called PEMDAS. Please excuse my dear Aunt Sally, parentheses, exponents, multiplication, division, addition, subtraction, or penguins eat mini donuts after school, whatever you'd like to fill in for the terms. Just remember that's the order of operations for solving problems in this mathematical sequence. We want to have that same sequence that we use each time so that we're doing math correctly in that order. Otherwise, if we bounce around, we do different operations at different times, we're all going to find different answers, which is not necessarily going to be correct. Letter A has 45 minus, in parentheses, 2 plus 4 times 5 minus 3. If I'm using my order of operations, the first thing I'm going to look at are those parentheses. 2 plus 4 is 6. Now, I like to make sure that I write out each and every step to the problem. That way I can see what is next in terms of my order of operations, and I'm not just working from left until right. Here I've got 6 times 5. 6 times 5 is 30, and I'm again going to rewrite those things, bring those down, and notice that I'm using the same terms. I'm bringing down the same expression in between. 45 minus 30 is 15, minus 3. 15 minus 3 is 12. Letter B, 9 times 2 to the third power minus 9 divided by 3. Using my parentheses, exponents, multiplication, division, addition, subtraction, PEMDAS, I'm going to use my exponents first because there are no parentheses. 2 to the third power is written out as 2 times 2 times 2, which is 2 times 2 is 4, times 2 is 8. I would write that here. Keep the next term and its multiplication there. Minus 9 divided by 3. Now I've got multiplication and division as my next set of problems. So I'm going to multiply 9 times 8. 9 times 8 is 72. I'm also going to divide, because that's the next step, in this one step itself. 9 divided by 3 is 3, and I bring down that term. 72 minus 3 is going to give me 69. In letter C, 15 minus 3 to the second power plus 4 times 2 divided by 7. Now, one thing to remember in our problem with a fraction bar in it is that it almost operates as if it's a set of parentheses itself, as in you need to solve this part of the problem first before you're going to involve the second part of the problem. So it's like there's an imaginary parentheses over that numerator and denominator to solve those. With that in mind, let's jump up to that numerator. No more parentheses, but we do have an exponent. 3 squared is going to give me 9. I'm going to rewrite this. 15 minus 9 plus 4 times 2. We would say 4 times 2 is 8. So I get 15 minus 9 plus 8. 15 minus 9 plus 8. Because addition and subtraction are right here in this order, I can work from left to right. 15 minus 9 is going to give me 6. Plus 8 is 14. Now I've got 14 as my answer in the numerator. If I would rewrite that, it would be 14 in the numerator over 7. 14 divided by 7 is going to equal 2. And say, well, Mr. Shane, you did division after you did addition and subtraction. Again, what we're solving in the numerator is like it's inside of its own set of parentheses, so we're going to do that first, then complete the problem by using that actual fraction bar to do the division at the end. So it separates that set of order of operations in that specific numerator. Then we can do the division at the end to come to that conclusion. In practice problem letter D, it asks us to compare the two sides of this expression to see which one is larger. Greater than, less than, or equal to is going to be our symbol right in here to show that comparison. We're going to break these into 2 separate problems and then use our comparison at the very end of each calculation. Again, using our order of operations, let's take a look at the left-hand side of the problem. There are no parentheses in this set, so we're going to start with our exponents. 3 squared, 3 times 3 is 9. And I've got 1/4 plus 9 plus 6. Now if I'm adding, they're all the same set of operation, I can follow a sequence that's going to be more helpful to me. 9 plus 6 is 15, plus 1/4 is going to give me 15 and 1/4. Okay? On the right-hand side, follow those order of operations. I don't see any parentheses, so it starts with exponents, so I don't see any exponents. Multiplication and division, I've got a set of multiplication and division right here that I can do. 2 times 4 is 8. 3 divided by 9 is going to give me 1/3, and I'll keep the same numbers and operations between those different values. So now I've got 5 minus 2 plus 8 plus 1/3. Again, with addition and subtraction, we can follow those from left to right. 5 minus 2 would be 3, plus 8 plus 1/3. 3 plus 8 is 11 and 1/3. The larger of those two values is going to be 15 and 1/4. Therefore, the alligator eats the larger number. We're going to have this as the larger portion. Letter E asks us to solve the problem that is a word problem, an application of what this order of operations would look like. Jonah is making a model of the moon using plastic foam. He uses the formula 4/3 pi r cubed to find the volume of that three-dimensional spherical shape. The model's moon radius, the radius is actually 3.5 inches, so 1 1/2 inches. What's the volume of the model moon? Give the answer in terms of pi. Now here I've written out that equation that Jonah is using, and I've already plugged in the radius for what would be the r value. Now to follow our order of operations, the first thing that we're going to need to do is our exponents. I'm going to rewrite that out so that you can see each part of what that exponent looks like in terms of our fractions. Remember, each part of the fraction is written out, and you're going to multiply numerators by numerators and denominators by denominators. So you have 3 times 3 is 9 times 3 equals 27. And the denominator, 2 times 2 is 4, times 2 is 8. You've got 27 over 8. I could rewrite that and have the answer be 4/3 pi 27/8, but we're not quite done yet. This actually is another set of multiplication that needs to be done because these are written as factors. If they're ever next to each other, that means that they can be multiplied. So I can multiply these two fractions together. Let's go ahead and do that. 4/3 times 27 over 8. Before I do any type of multiplication, I can actually do some simplifying. What I like to think about is the smaller value fitting into the larger number. So I have some canceling to do between 4 and 8 because there's like factors. 4 fits into 8. Well, how many times does 4 fit into 8? I would say 2. I cancel the 8, turn that into a 2. How many times does 4 fit into itself? Turns into a 1. The other way in which you could do this, 3 and 27 have common factors. So you're going to think to yourself, how many times does 3 go into 27 to cancel those out? 27 is going to turn into 9, and 3 turns into 1. Now I do my multiplication. 1 times 9 is 9. 1 times 2 is 2. My final answer then is going to be 9 over 2, and it's write it in terms of pi. So I would have pi as my answer. Now the units for something in volume is cubic. We were in inches cubed. There's my final answer for what that would look like in terms of applying those order of operations.